Hey everyone, I am Pranshi everyone and welcome back to my YouTube channel. Today we will be solving today's Leetcode daily challenge, which is maximum number of fish in a grid. Okay, so let's see what is this question and how we can solve it. So in this question, you are given a zero index 2D matrix grid of size n cross n, where R, C represents either a land cell if the value is 0 or a water cell if the value is greater than 0 and the water cell contains a fish. Okay. And a fisher can start at any water cell R, C and can do the following operations any number of times. Catch all the fishes at cell R, C or move to any adjacent water cell only. And we need to return the maximum number of fish the fisher can catch if he chooses his starting cell optimally or zero if there is no water cell exists. And adjacent cells are the cells which are in the north, east, west, north, south directions. Right? Okay. So what we are given in this question is we are having given with a grid with values 0 and greater than 0. And 0 means a land cell, and the value greater than 0 means a water cell containing a fish. And the number represents the number of fishes. And we need to find that a fisher can hunt how many maximum number of fishes. If he starts, if he chooses a starting cell optimally, because if the adjacent cell is a land cell, then he cannot move into that cell. Okay, so first let's say we start from 2. Then the fisher will collect 2 fishes and then 1 fishes. 1 fish. It means 3. Okay, now he can't move to the adjacent size as these are land size, right? These are all land size. Okay, and then if he starts from this, then he will be able to collect 5 fishes. Here he will be able to collect 7, and here he will be able to collect 5. So, what is the maximum value of all of this is 7. So that's why the output is 7. Okay. So what you can see from this observation is that we just need to start from a point having fishes and need to iterate all of its neighbors which contains the fishes. Simple, right? So we just need to do a simple either DFS traverser or BFS traverser in which we will start from a cell containing the fishes and then iterate all of its neighbors and then again take a set with the fishes and then iterate all of its neighbors. You can use any of the DFS or VFS, but DFS code is usually shorter than the VFS one. So I would always prefer DFS, but I will show you both the codes. Okay, so what we can do in the DFS traverser is that you can see I have created a visited vector, so we should not keep on going on a single cell again and again, and it's got stuck in an infinite loop. And initialize the maximum fish with 0, and we will iterate each cell if it contains a fish and it is not visited, and we do its DFS traverser. Okay, so let's see what it will do is that let me just create this grid here as well. 0, 2, 1, 0, 4, 0, 0, 3, 1, 0, 0, 4, 0, 3, 2, 0. Let's suppose if we start the DFS, if the first index is this, then we are calling the DFS on this index, right? So the fisher will collect the 2 fishes, and then we go to its neighbor and then collect this fish, and then we go to its neighbors, but there are no neighbors, and then we again come back to this one only. So I hope you know that what is the DFS and BFS traverser. So let's say if we have some kind of matrix, this 1 1 0 0 1 0 1 1 0. So if we have some matrix this, then what will happen? First, we start from this, and then for in DFS traverser, what happens? It will go to its neighbors, and then it will go to its neighbor. Like whenever in DFS traverser, whenever we reach to a cell, then we keep on going deeper and deeper and deeper to that cell only. And in BFS traversal, what happens? We first iterate all the neighbors of a particular cell and then go to the next cell, right? So right now we are talking about DFS. So here we will start from 2 and then it will iterate for one neighbor of 2, that is 1, and then there are no neighbors of 1 which contains fish. So it will come back and it will come back and it will finally return 3, right? So as you can see, we are calling the DFS, and in the DFS we have implemented some base conditions like if row and column are not in the bound of 0 comma n or 0 comma m, and if it is not a fish cell, then we will simply return 0, else mark it as visited and initialize the fish count with the current cell value, which is the current number of fishes we have, and then we finally iterate in the we are making a DFS call in the to for the neighbors of that cell. And finally, we are returning the fish count. What our DFS function will return the total number of fishes a fisher can collect in that iteration. Okay. And what will be its BFS code? So like instead of making this function as GFS, we can make it as BFS only. So let's see that code as well. So in this code also, we are iterating all the cells. If it is a fish cell and it is not visited, then we will do a BFS on the grid. Okay, so let's see a BFS as well. So we will initialize a queue, push that row column in the queue and mark it as visited and initialize the fish count as 0. And then we will create a queue so that we can iterate all of its neighbors, right? So we have initialized the queue, and then we are we are counting the total number of fishes in all the adjacent cells, and then going to all the adjacent cells, and then these are some base conditions like 0 comma n, and it should be in the 0 comma n block, and it should be in the 0 comma m block, and it should be a fish cell, and it should not be visited. Then we will push it in the queue and mark it as visited. So I have created this direction vector here. These are all the 4 directions: east, west, north, and south. And similarly, this BFS function will also return the total number of fishes the fisher can collect in that iteration. Okay. So I hope you get it. It is simple. It is a very simple DFS and BFS traversal. I would prefer DFS as its code is smaller than the BFS one. Okay. So now let's talk about its time and space complexity. So its time complexity will be big of m into n only because we are iterating on all the cells of the grid in both of the algos, DFS and BFS, and its space complexity will also be m into n as we are creating this visited vector, right? So I hope you get this question, but if you still have any doubts, then you can post in the comment section. I will surely try to answer them. Till then, bye guys, see you in the next video.